Next up, we're going to talk about work and power. Let's start, though, with work. So simply put, work is when a force is applied to an object and it causes it to move a distance. So if you're pushing on something and you get it to move, you've done work, okay? And it's a very simple formula. All the formula is work is equal to the force times the distance, or the change in distance. That's why we have that delta there. But it's work is equal to force times distance. Look, we can put it in the fun little pyramid so you can figure out how to do this. So I don't have to break that one down into its individual components. If I wanted it for force, I would simply cover force, and I would see that it's work divided by distance. If I wanted distance, I would cover distance, and I could see that it's work divided by force. Now, this has a whole bunch of information, but really it's just the idea that work is an energy. So anything that has an energy output is going to use the unit of joules. A joule, you can basically say, is 1 Newton meter, but it is a derived unit, so we just say that it's joules. And so that's what you would measure work in, because work is energy. Think about it. It takes energy to do work. Work is energy. Let's try a couple of quick questions. So we have an elevator. It lifts a group of people with a force of 5,400 newtons up 10 meters. What is the work done? Well, we know that work is just equal to that force times that distance. So now we can plug in that it was a force of 5,400 newtons. And we're multiplying that by 10 meters. And we're going to get that the work is 54,000 joules. So that one was straightforward, but this next one's slightly different. We can see that a weightlifter's lifting weights. It has a force of that. He used 4,900 joules. I think this question's wrong. It should say work there, right? Work. How far did he lift the mass? Well, now we just need to rearrange that formula that we had right up there. We can do it for distance. And remember, I already told you that's just work divided by force. Now I can plug in my values. 4,900 joules divided by 490 newtons is going to give me basically 10 meters, because remember, that's what distance is measured in. All right, so not too bad. A man applied a force of 500 newtons to a ball. The ball traveled 100 meters. What was the work done? Oh, lucky us. This one's super easy too, because it's straightforward. The work is simply equal to the force times the distance. We have 500 newtons. Going to multiply that times 100 meters, and we're going to get 50,000 joules. That's it. Next up, we're going to need to talk about power. So let's take a look. So power is probably not what you're thinking of. It's simply a rate. And remember, all rates are just a proportion of something done over time. So this is the rate at which work is done. And so it's directly related to work. Now, there is something where I don't want you to get too confused with. Power is measured in watts, and we represent that unit with a W. If you notice, though, work symbol is a W. These are not the same thing. If it comes after a value, like 53, that means that's a power, and that's being used as a unit. If it's used in a formula, such as up here, then that means that it's work, okay? So it's the same letter, same representation, but it means two different things depending on if it's after a value or if it's in a formula. Don't get confused by that. I've had several that have. And that watt is nothing more than joules per second, but it's another derived formula, and that's where we get watts, okay? Here's our formula for power. Is just work divided by time, as we talked about before. So you have power represented in watts, work represented in joules, and time, change in time is why it has a delta, in seconds. Needs to be in seconds. But if you would look right here, I say that power can also be represented as force times velocity. Well, you need to think about what that is. If normally power is work divided by time. Well, how do we get work? It's force times distance. So let's write it out again. It's P equals force times distance divided by time. Oh, but wait. We also remember that velocity is equal to distance divided by time, which is that right there. And so this is really just force times velocity is all that is. But it's much easier to understand it as power is work divided by time, because it is the rate at which work is done. So let's look at some problems. And this first one is pretty much conceptual. So let's just think about it. So you got two students. You got Will and Ben, right? They're both lifting weights. They both lift 100-pound barbells. They both do it 10 times. Will, however, takes a minute to do his, while Ben takes only 10 seconds. Now, it asks, who did more work? Well, what's work? Work is force times a distance. They lifted the same amount, right? So gravity would be affecting the same, so it's the same force. They both had to apply the same force. They both lifted it over their heads the same amount of times. So really, this first part is a trick because they did the same amount of work. Neither student did more work. They did the same amount. It's just that they did it at different times. And that's where power comes into play. So Will took a minute to do his, and Ben only took 10 seconds. So that means Ben had to have much more power because he was dividing by a smaller number of time. So he's going to do it at a greater rate, right? So that means that Ben would have had more power. All right. Second one, it's where we might have to do a little bit of work, but it shows you how you have to calculate work before you can get power. So you have a tired squirrel of approximately 1 kilogram. That's actually a fairly hefty squirrel. Does push-ups by applying a force to elevate its center of mass 5 centimeters. Now, if we were calculating this, we would have to go ahead and convert that into meters, and we would end up multiplying or dividing it by 100. But I did it for you, so you just get 0.5 joules of work, okay? So that's all the work that you did. If the tired squirrel does this work in 2 seconds, determine its power. Well, that's a pretty easy problem, because remember, all we really need to do is we said that power is equal to work divided by time. And so we already have that 0.5 joules is the work, 2 seconds is the time. Oh my. So we're going to get 0.25 watts as our overall result. Okay. Number 3, when doing a chin-up, a physics student lifts her 42-kilogram body a distance of 0.25 meters in 2 seconds. What is the power delivered by the student's biceps? Well, there's a problem here. They just give you a mass, a distance, and a time. And if you remember, we, for power, need work over time. Luckily, we know that work is equal to force times distance. And we're also able to say that force of gravity is equal to mass times little g. So we actually have to do 3 different things just to get this one. First, we have to say that 42-kilogram student times 9.8 meters per second squared, and we get the force of gravity is 411.6 newtons. We then can plug that into our work formula and say, and we now have 411.6 newtons, and we multiply that by the 0.25 meters, and we get that the work is actually equal to 102.9 joules, and we divide that by 2 seconds, and we get, I need to write it somewhere else, I'll write it in red up here, that the power is equal to 51.45 watts. All right, and that one goes for that answer. Okay, that's how we do it.